What's going on, guys? My name's Jake. I'm a building engineering student, and in my first video I'm going to do a simple walkthrough of how to solve or find the sum of the moments acting about point A on this cantilever beam in our example here. So what I like to do in simple problems like these is first identify a few things. So we got to find our point A. So we can see in this example right here. Pretty simple. It's usually the easiest first step. Next thing I like to do is find all of our forces and just kind of list them somewhere on our page. So for this example, quite simple, only one force. So we can just call this F1. Over here equals 90 newtons. The next thing I like to do is determine how far our force is from our point. So for this example, we can see the bottom here, 7 meters from point A. So with this, there's a few things you need to know. You need to understand that this 90 newtons, since it is at a 35-degree angle, you need to break it up into two separate forces. So if we go over here, we can draw just a little, kind of like a free body diagram, but not quite. So we can take our 90 newtons. What you want to do, as we zoom in here, is title this force going down in the y direction, F1y. And then we look at this, and to me it looks like this force is going down and over. So that means on this point, our next force, F1x, is going in the negative direction, we can call it. So next, I like to do this fairly early, and that's determine whether our forces are positive or negative. So over here we can do sum of our moments is in a counterclockwise positive direction, meaning that all forces doing a counterclockwise turn about the point are positive, and then anything going this way, it's a bad arrow, is negative. So now that we have this, we can do one more thing, and that is explain the F1x and F1y. Well, explain to some extent. So to find F1x and y, we have to go just do a simple kind of formula. They are easy to remember once you get doing them. I'm just calling it simple because it is now, and I've only been doing it for about a year. But after the first few, you do a few questions and you kind of get the hang of it, and it becomes like second nature. And this is coming from someone who struggled with stuff like this for probably a couple weeks. So if I can do it, you can do it. So we come down here, F1x equals. So for anything in the x direction, we always go our force total, so 90 newtons. 90 cos, so anything in the x, you gotta remember that, is cos. Just try and remember cos is x. And then I'll say it now, sine is for anything in the y. So we go 90 cos our angle, which is our angle from 0. So it'd be this angle here, 35 degrees equals. So now we need to grab our calculator. Into the calculator we go 90 cos 35 equals 73.7. 73.7 newtons. So once we have this answer here, which is our force acting upon point A in the x direction, we have to find the moment that this creates. So by doing this, we simply look at our x, and what you need to do is multiply your x forces by your vertical distance from point A, if that makes sense. So whatever you find acting in the x direction, so that way or that way, you multiply by the vertical distance. So in our case, if we look at our example, we have our 73 newtons, 73.7 newtons acting in this direction, okay? Then we look, okay, what is our vertical distance from this point to point A over here? Well, it's 0. There's no height between right here and right here. You can draw a perfectly straight line, so there's no height. So this is like makes this problem even easier. So we go times 0 equals 0. So there's no moment, like that doesn't amount to anything. It's still a force, but it doesn't create any rotational impact about point A. So now we come down here, F1y, similar fashion, we go 90 newtons, sine, because we got to remember this rule over here, 35 equals 51.62 newtons. So then we look at this, and since we multiply our x values by the vertical distance from A, we do the opposite with our y. So now we have 51, write this here. So we have our, draw another one of these. We have our 51.62 newtons going down. We look and try and find our vertical distance from this point to point A, which happens to be down here, 7 meters. So we can take this, multiply by 7 meters, which gives us 51.62 times 7 meters, gives us 361.34 Newton meters. So we think we're finished, but we're not. You got to remember this over here, how moments going counterclockwise are positive and clockwise are negative. So what I like to visualize is I come back up to the initial drawing. I'll draw some blue, it might be easier to see. I draw my Fy, F1y, and I attach a string, let's just pretend it's kind of a wavy string, to this point. Try that again. So we attach our string or our rope, and then basically pretend you're holding on to this force and you let it go. Which way is your F1y going to travel around point A? Well, since it's going down, it's on this string, I'd imagine it's going to go something like this. And then if you remember this rule, meaning that anything going clockwise about point A is negative. So we have to take our 361.34, and basically I just like to kind of go equals negative 361.34 Newton meters. I just find that's an easier way to do it. And then even if you want, you can go one step further. I know my professor likes to have this just to show, basically to tell you that this is a clockwise moment. So you can go sum of moments A equals minus 361.34 Newton meters. And that's it. So yeah, this is my first YouTube video. I don't know, I just kind of like to explain stuff like this to people. I know that I've struggled with it before, and finding a YouTube video that's really helpful online is always awesome. So yeah, if you guys like this type of content, just drop a like or a subscribe, maybe a comment. And yeah, I hope to catch you guys for future videos. Peace.